48 light-years away, there is a world with no sunrise and no sunset. Not because it never sees the light, but because it never stops seeing it. One face of this planet burns under a red star forever. The other has never known daylight, not once, not for a second. Between them runs a line, not a moment, not an event, a place, a permanent border between fire and dark. Scientists call it the Terminator. This world has two of them, two twilights, that never move, never end, never touch. This is LHS 3844b, and its story is about to get stranger. Let's find it first. Look toward the constellation Indus, 48.5 light-years from where you're sitting. There, a small, dim red star holds onto a single, tortured planet. The star is called LHS 3844. The planet, LHS 3844b. It was found in 2018 by NASA's TESS spacecraft, watching for the tiny shadow of a world crossing its star. This planet is close, unbelievably close. Closer to its star than Mercury is to our Sun, so close that one full year here lasts just 11 hours. 11 hours to go from one side of its star to the other, and back. Size-wise, it's a big cousin of Earth. About 1.3 times our radius, twice our mass, dense, rocky, and real. But everything about how it exists is nothing like home. Here's the thing about orbiting that close, that fast. Gravity doesn't let go easily. Over millions of years, the star's pull grabbed this planet and stopped its spin, locked it. One hemisphere permanently facing the star, one hemisphere permanently facing away. On Earth, twilight is a moment. It sweeps across the globe every single day, visiting every point on the map, then leaving again. Not here. On LHS 3844b, twilight never moves. It isn't a time of day. It's a location. Two fixed rings of half-light, frozen exactly where the dayside meets the night. For as long as this planet exists, stand on one, and the star hangs motionless on the horizon. Forever. Stand on the other, and it's the same. A horizon frozen in the exact instant of dusk. Two twilights. Never moving. Never merging. That's the setup. Here's where it gets beautiful. Picture it happening. Billions of years ago, this planet spun freely. Day-night and day-night. Every few hours, a new sunrise. But gravity is patient. Orbit after orbit, the tug of the star drained its spin away. Slower, slower, until one final rotation, it stopped and locked and frozen. From that moment on, one face of this world has stared directly into its star, unblinking, for longer than complex life has existed on Earth. Surface temperatures on that dayside climb past 800 degrees Celsius. Hot enough to melt lead. Hot enough to melt silver. On the far side, a night that has never once broken. Cold enough to freeze the atmosphere itself, if there were one to freeze. And running between these two extremes, not a smear, not a blur, a line, sharp and exact. The two twilight zones, locked in place, dividing a furnace from a tomb. This is what a truly airless world looks like from space. No haze to soften the edge. No wind to blend the boundary. Just a knife cut between two permanent worlds on one small planet. Here's the question that mattered most. Does this planet have air? Even a little? Because if it did, wind would carry heat. Wind would drag warmth from the scorched dayside, past one twilight zone, toward the frozen night. And that would show up as a lopsided glow. A hot spot pushed off center. So in 2019, astronomer Laura Kraidberg and her team pointed the Spitzer Space Telescope at this planet for over 100 hours, watching it complete orbit after orbit, mapping exactly where the heat was. If there were an atmosphere, the two twilight zones would look different from each other. One warmer, one cooler, evidence of wind, of motion, of air. The result came back. Symmetric, no offset, no lopsided glow, no wind-blown warmth. The hottest point sat exactly where the star shines straight down. Nowhere else. Both twilight zones behaved exactly alike, which means only one thing. There is no meaningful atmosphere here. Not a thick one. Not a thin one worth mentioning. Just bare rock, basalt, most likely doing the only thing bare rock can do. Absorb heat, radiate heat, nothing in between. So why does a planet with nothing matter so much? Because nothing is data. LHS 3844b is what happens to a rocky world, parked too close for too long to an angry young star. Whatever air it may have been born with was almost certainly stripped away, boiled off, blown into space, gone. Worlds like this are a warning label and a control group for every rocky planet we find near small, active stars, including one-day planets we hope might look like home. Understand the bare ones, and you understand what a planet needs to keep its air at all. That's why LHS 3844b is now a prime target for JWST. Not to find life, to read the recipe for its absence. Two twilight zones, fixed in place, unmoving, unmerging, a permanent boundary between fire and dark, on a planet with nothing to blur the line. That's LHS 3844b, a world defined by what it doesn't have. If you want to keep exploring worlds like this one, subscribe and ring the bell. There's a lot more universe left to see. Keep looking up.